We now look at review problem 2.7. We have a number of families that are surveyed, and amongst part of the survey, they look at families that have only exactly 3 children. If a family has 3 children, they could have either 0 girls, 1 girl, 2 girls, or 3 girls. And they found 76 families that had 0 girls, 280 that had 1 girl, 302 that had 2 girls out of 3 children, and 116 that had all 3 children that were girls. And the question is, does this distribution follow a binomial 3 1/2 distribution? Now that's a fancy way of saying that 1/8 of the families fall in the first category, 3/8 of the families fall in the second category, 3/8 of the families fall in the third category, and 1/8 fall into the fourth category. That's because if you compute 3 choose 0, 1/2 to the 0, 1/2 to the third, that works out to be 1/8. For this block, if you compute 3 choose 1, 1/2 to the first, 1/2 to the second, that works out to be 3/8, and so on. So if you actually work out all the possible probabilities for a binomial 3 1/2 distribution, it comes out to be 1/8, 3/8, 3/8, 1/8. All right, there are the observes. Let's get the total number, so I'll need to add these up. And I will be using Excel for this computation. If you do not have Excel, you can use the spreadsheet on your calculator. If you don't have that, then simply these calculations can be done by hand. So we get 774. So that's the observed. The expecteds will be equal to 774 times 1/8 in this block, 774 times 3/8 in this block, 774 times 3/8 again in this category, and finally 774 times 1/8 in this category. So those are the observeds minus and the expecteds. We now begin to compute the Chi-Squared Statistic. And to get the Chi-Squared Statistic, we need to do 4 fractions. Taking the observed value minus the expected value, squaring that difference, and then dividing by the expected value. So using Excel, we get B2 minus C2 squared over C2. So 76 minus 96.75, quantity squared, all divided by 96.75. And that is that contribution to Chi-squared. If I repeat that 4 times, then this last one would be 116 minus 96.75, quantity squared, over 96.75. Then adding these 4 numbers up gives us our Chi-squared statistic of 9.118. So our Chi-squared statistic is 9.118. So now we have to determine if this number is big or if it is small. To determine if it's big or small, we remember that the Chi-squared distribution kind of looks like this. We have a axis that looks like this. We have a Chi-squared distribution with 3 degrees of freedom in this case. The number of degrees of freedom is equal to the number of categories minus 1, so a Chi-squared distribution with 3 degrees of freedom. 9.118 is out here, and I need to find the probability of seeing something this extreme or more extreme. So let's go ahead and type that in. So remember to don't forget to do this on the exam so you don't get docked. H naught, the null hypothesis, will simply be that the observed values follow the 1 to 3 to 3 to 1 distribution. The alternative hypothesis will simply be that the observed values do not follow the 1 to 3 to 3 to 1 distribution. So don't forget to write those down on the exam. If the null hypothesis is true, then I got a Chi-squared value of 9.118, and then I will use, there's 2 ways I can determine whether or not that number is large. The first thing I can do is figure out the p-value. And for Microsoft Excel, we have chi-sq.dis.rt E103, pardon me. The area to the right of 9.118 for under a chi-squared distribution with 3 degrees of freedom. There is an analogous command on a TI calculator, and so we get 0.0277. So I get a p-value, the area here is 0.02776. That number is less than 5%, and so we will end up rejecting the null hypothesis. The other thing that could have been done is to figure out the, I'll mark it here, critical value. And the critical value we get by chi-squared inv right-tailed. And if I have the significance level of 5% and 3 degrees of freedom, that means I get a critical value of 7.814. That number also could have been obtained through a table that will be provided on the exam. To my knowledge, this cannot be obtained using a TI-83 calculator, though it's possible that a more advanced version of the TI calculators could do this. So what this number means is that the area to the right of this red line is 5%. So that means that if the value 9.118 falls to the right, which it does, I will end up rejecting, because the area to the that's been shaded is going to be less than 5%. On the other hand, for the sake of argument, if the test statistic fell to the left of 7.815, then the area would have been bigger than 5% and I would retain. So 9.118 is bigger than 7.815, so I reject the null hypothesis. Stated another way, 0.02776 is less than the value of alpha, which is 5%. So using either technique, we decide to reject the null hypothesis. So our conclusion is we reject the null hypothesis. It does not appear that the numbers follow a 1 to 3 to 3 to 1 ratio. So that's possibly a somewhat surprising result. You would think that the probability of boys and girls in the family is about 1/2, but that did not come to fruition when counting the number of girls that appear in a family with 3 children.